Hello class, this is Mr. Lehman. I'll talk to you today about some more advanced mole conversion problems. So I have two problems here that we're going to take a look at together. And the first problem deals with table sugar, sucrose. And sucrose has a formula: 12 carbons, 22 hydrogens, 11 oxygens. And so the question is, if we have a 20-gram sample of sucrose, how many atoms, not how many molecules of sugar, but how many oxygen atoms are there in that sample? And so take a minute, pause this, try to figure out the molar mass of sucrose. Alright, welcome back here. For the molar mass of sucrose, you should have figured out that it's 342.34 grams. We take how many atoms of each are in the formula, multiply it by how much the mole of each one weighs, and we get the grand totals for the elements. And so this is the molar mass for sucrose. So this is what we're going to plug into our conversions. So let's go ahead and let's set the problem up. So we're going to take what we know, 20 grams. And I'm not going to include units. I like to write sucrose, but I'm going to run out of room. So 20 grams of sucrose, we put it over 1. To go from grams into moles, we divide by the molar mass. So the molar mass, 1 mole of sucrose is equal to 342.34 grams of sucrose. And so grams of sucrose will cancel. We're now in moles of sucrose. And if we know how many moles of something we have, we can multiply it by 6.02 times 10 to the 23rd, and that'll give us the number of molecules of sucrose per mole. So moles cancel, but now we have to look back. That's how many molecules of table sugar we have. So we gotta look at oxygens. So per molecule, there's 11 oxygens, right? Look at our chemical formula. So one molecule is this. Per molecule, there's 11 oxygens. So for every one molecule we have 11 oxygens. So we're going to use that as our last conversion. So 1 molecule of sucrose contains 11 oxygen atoms. So molecules of sucrose cancel. And let me put a little dash here so you can see it's 11, not 110. 11 oxygen atoms. So we're going to multiply everything across the top, divide everything on the bottom. So it's basically 20 divided by 342.34. We're going to times that by 6.02 times 10 to the 23rd. We're going to times that by 11 to compensate for 11 oxygens per 1 molecule. And we get a final answer. And we're looking at, these are counted numbers, infinite number of sig figs, 3 sig figs, 5 sig figs, 4 sig figs. So we only can keep 3 sig figs in our answer. And so you should have gotten 3.87 times 10 to the 23rd atoms of oxygen. Alright. We're going to take a look at one more problem. So if we take a look at one more problem, we're going to work backwards this time. So what is the mass if you have 3.72 times 10 to the 22nd formula units of aluminum oxalate? So this is where memorizing your ions comes in handy. We know aluminum is +3, oxalate is -2. So our chemical formula would be Al2, and then we would need 3 of our oxalate to get so that we have a neutral compound. So this is what we have to figure out the molar mass of, and so we'll do that on the next slide. So we have Al, we have carbon, we have oxygens, we have 2 aluminums. Since aluminums are not inside the parentheses, we have 2 carbons inside the parentheses. We have to multiply it by the subscript. So if we have 3 of all the groups inside, 3 oxalate ion groups, 3 times 2 is 6, 3 times 4 is 12. So we have 6 carbons, 12 oxygens, and so we're going to multiply aluminum, which is 26.98. I'm not sure what happened there to my pen. We'll try that again. 2 times 26.98 is equal to 53.96 grams of aluminum. Carbon, 6 times 12.01 is equal to 72.06 grams of carbon. Oxygen, 12 times 16 grams per mole. Let's see, that's 32, 64, 96, double 96. We have 192 grams of oxygen. Get the grand total. We get 2, carry the 1, 10. carry the 1, 4, 5, 6, 7, 8, 5, 12, 21, carry 2, 2 and 1 is 3. Alright, so we get the molar mass for aluminum oxalate as being 318.02 grams per mole. So now how do we set the problem up? This is what we know. This is how many formula units. Formula units are basically saying the simplest ratio of ions within that crystal lattice. So it's almost like the chemical formula of a salt. So we're going to take, and I'm sorry, I just forgot the number, 3.72 times 10 to the 22nd. So take what we know, put it over top of 1, and what do we know? We know that 1 mole of a material contains 6.02 times 10 to the 23rd formula units. So units of formula cancel out, leaving us with moles. Once we know the moles of material, we're going to multiply it by the molar mass, and we established that the molar mass is 318.02 grams per 1 mole. So a mole divided by a mole cancels out moles, so we're left with the units of grams. So this is where it gets tricky in your calculator. Make sure you put each scientific number, scientific notation number, in parentheses. Otherwise, your calculator will not see that as 2 numbers. It'll see it actually as 4, and you will not get the right exponent. So I'm doing this right now as you're waiting. So pause this, get an answer. When you have an answer, check back with me, and we'll see how you did. Alright, so the answer that I got is 19.65 grams of aluminum oxalate. How many sig figs can I keep? 3 sig figs here, 3 sig figs here, 5 sig figs here. So I only can keep 3 sig figs. So I need to round this to 19.7 grams. And that's it. Hope this helps. Check back. I'm going to do one more tutorial here soon, and we're going to take a look at percent composition, and actually early next week we'll take a look at empirical formulas.